completing the square is another method of solving a quadratic equation. So you can complete the square, you can factor. We're learning about using quadratic formula. We've solved it using square roots. So the idea of completing the square is this idea that if we can create a perfect square trinomial, then we can solve an equation by using the square roots. So if you look at your example, it says given the left side of the quadratic equation is a perfect square trinomial, solve using the square root method. So it's telling us that this side is a perfect square trinomial, and it is. Square root of 16, square root of x squared, x and 4. How do we get to negative 8? They have to both be negative. So you can rewrite x minus 4 and x minus 4 as x minus 4 squared equals 25. So now you guys can solve using your square root. So that would go away. You'd be left with x minus 4 equals plus or minus 5. Add the 4 over, and x would be 4 plus or minus 5. So 9 or negative 1. So if we can create a perfect square trinomial, we can solve any equation using square root method. So here's the problem. They're not all going to be perfect square trinomials. Completing the square is the process of making your equation a perfect square trinomial. So let's go ahead and look at them. So before we work with actually solving an equation, let's just try and put it into or create a perfect square trinomial before we worry about solving it and putting it into vertex form. So it says find the value of c that makes the x squared plus 6x plus c a perfect square trinomial. Then write the expression as the square of a binomial. So what's going to happen, I'm going to say x squared plus 16x plus what? This is what we are trying to find makes this a perfect square trinomial. Well, if you guys remember me saying, when we have a perfect square trinomial, so say we had, just as an example, x squared plus 10x plus 25. I said it's the square root of the first times the square root of the first or the last doubled. So the square root of the first is 1x, square root of the last is 5. So 1x times 5 doubled is 10x. And not 10x squared. So a perfect square trinomial is the first square root of the first times square root of the last and doubled. So we're going to sort of work backwards. Instead of taking the square root of that and doubling it to find the middle, we're going to take the middle, divide it by 2, and square it. So how this works is we take this middle term, divide it by 2, and square it. So if it's a perfect number or a whole number, we like that. But sometimes it won't be, and that's when I'm just going to leave it as a fraction. But in this case, 16 divided by 2 is 8. 8 squared is 64. So that's going to be the value C that makes this a perfect square trinomial. So if we try to write it as a squared binomial, it would just be x plus 8 times x plus 8, or x plus 8 squared. Square root of 64 is 8, square root of x squared is x, first times last, so x times 8 doubled. So we work backwards. So the theme of completing the square is dividing that middle term by 2 and squaring it. So divide by 2 and square. So we do have some steps for you guys when you're trying to complete the square. Sometimes I think the steps are a little more confusing. Make it a little more confusing, but for those of you who like steps and you like step 1, step 2, do this, step 3, do this, they're great. So when you guys are completing the square, now the ones we've done so far have all had a lead coefficient of 1. They've just been x squared. But say it was 4x squared or 3x squared. That first step you guys would want to do is divide the entire equation by that a value. So the number with the x squared, because you want that to be 1. So then, once you guys have your lead coefficient of 1, so that's what it's saying here. We've divided by that a. We want to subtract the c term over. So that c term needs to get moved to that other side so we can find that term that's going to make it a perfect square trinomial. And then step 3 is once you get whatever that perfect term is that makes it a perfect square trinomial, you add that to both sides. Because remember, it's an equation and it has to stay equal. And then the last step is writing the left side as a squared binomial. So let's look at it's number 4 through 6 in your book, but I wrote them there for you guys just as practice. So if we try to do number 4, it says x squared plus 14x plus what gets us to a perfect square trinomial. So remember, you take the b term, the one right with your x, divide by 2 and square. So 14 divided by 2 squared equals 7 squared, which is 49. So x squared plus 14x plus 49 would be our perfect square trinomial here. So if you look at number 5, x squared plus 22x, x squared plus 22x plus what gets us to a perfect square trinomial. So you would take your b term, divide by 2, and square. So 11 squared equals 121. So 121 is that c term, that term that makes it a perfect square trinomial. So we could write these guys as squared binomials. So we could rewrite this as x plus 7 squared. We could rewrite this as x plus 11 squared. So it's always just half of that middle term, if you guys are recognizing a pattern here when you guys are trying to do this. So if we look at number 6, it says x squared minus 9x plus what? So if we take 9 divided by 2 and square. Okay, you could get 9 divided by 2, realize it's 4.5, and do 4.5 times 4.5. But it's a lot easier, guys, to just remember those exponent rules and remember that if it's 9 halves squared, then it's really just 9 squared over 2 squared, which is 4. So that is our term, or our c term, that makes us a perfect square trinomial. So when we're doing this, and we're writing it as a squared binomial, this would be x minus 9 halves squared. Matches your sign in the middle. Half of 9 is 9 divided by 2. So that's all there really is to it, guys. Finding that middle term, making sure your lead coefficient is 1, but dividing that b term by 2 and squaring it. That's all we're doing.